The chain rule is an operation in calculus that we use when taking a derivative of a function that's basically a function of a function. When I was in class, I used to tell my students to just put their thumb over this and pretend that's just a variable. And if that was just a variable to the third, it would be 3 times that variable squared. In this case, you do exactly the same thing, except you then multiply by the derivative of what's inside that bracket. And then we simply bring the 2x and the 3 together to simplify it like that. Now, one of the explanations for this is to break it down again into a function. Y is a function of u, and then u is a function of x. This is just this written in a slightly expanded manner. The derivative of y with respect to u is simply 3u squared. And the derivative of x squared plus 5 with respect to x is 2x. And the name chain rule comes from the fact that this is kind of a chain. You're taking the derivative of y with respect to u and then the derivative of u with respect to x. So it's like a chain. You can almost think of canceling these two out. You can't really do that, but that's the order from there to there is what you see in your original expression. Now, when I put this in, this is just the 3u squared from up here. This is just the 2x that I've got there. Then I replace the u with what it stands for, which would look like that. And again, put it back together. And you'll see it's exactly the same as what I've got over there. Now, in actual practice, this is all you're going to do. This is the explanation. And sometimes problems are set up in this manner, and you'll use that. I'll give you one of those examples in a minute. You encounter the chain rule when you go to take the derivative of the root of a function. You notice I've written this to the power 1/2 because in order to use my power rule, I need it in that form. So the first part of the derivative is 1/2 times this to the negative 1/2 times the derivative of what's inside that bracket. That's fairly simple, just 6x squared plus 5. And when you put this back together, I want it to look like this in my final answer. And you notice this is a root, but it's on the bottom because it's a negative exponent. So the only thing left on top is the 6x squared plus 5. The 2 and this root are on the bottom. Every time you take the derivative of a root function like this, you will end up with that same square root on the bottom. Now here's an example with a 5th root. We handle it the same way. Notice the 5th root, I put a 5 under here. This is just to the 3/5. Now when I take the derivative of this and I subtract 1 from that, I'll be subtracting 5/5, and that drops me to negative 2/5. And again times the derivative of what's inside, which is simply 3. The 3 times the 3 is 9. That's all I have on the top. On the bottom I have 5. Notice once again, this is the 5th root. If you start with the 5th root here, of course you'll still have a 5th root, and that's the power that we got right here. Now, as I mentioned in the first example, sometimes problems are set up as a chain. My problem here is to find the derivative of y with respect to x when x is negative 2. I've given y as a function of u, and then u as a function of x. So I simply take those expressions. Now I've rewritten them in a slightly different way. There's to the 1/2 again, like I did in the last example. I wrote the u cubed on the bottom as u to the negative 3 on the top. So that when I go to take the derivative, 3u squared plus 9, because you're multiplying u to the negative 4. That drops from negative 3 to negative 4. This is what I talked about before. The 1/2 comes down. When I subtract 1 from 1/2, I get negative 1/2. and there's the derivative of what's inside. And when I tidy these up, you see all I do is I put that u to the negative 4, make it u to the 4 on the bottom, and here my 2's, 2 divides into 2, and I just have that root on the bottom. So when I put it back together, that's what I talked about earlier, dy by dx is dy du times du dx. Now I'm told to evaluate this when x is negative 2, so I go back here, I put a negative 2 in here, that gives me a 1 in the root sign, and the square root of 1 is 1. That's what I worked out over here. So when I put these expressions that I obtained up here in for this expression here, and I evaluate, I put in negative 2 for x. When I put a negative 2 in there, I get the square root of 1, which is 1. When x is negative 2, u is 1. This is fairly easy to do. If that hadn't turned out to be 1, this would be a lot more complicated. And this is just 12 times 1, which is 12. So it's just a matter of going back, and they give you enough information at the beginning usually to make an evaluation. Now this is a question that I found in a textbook. Why is a function of the square root of x squared plus 9? And this symbol here, f prime at 5 equals negative 2, this is the dy du. This is the very beginning part of that chain rule. This is the derivative of the original function evaluated when x is 5. So we're supposed to find dy dx when x is 4. So you kind of wonder, where's this 5 going to show up? But they always do that. They make sure that you'll be able to come up with that number further down in the development. This is my original function. And this line right here is the dy by du dx. Now, I didn't write dy by du there, but that's this expression that they gave me up here. That's the first step in the chain rule. And then it's times the derivative of that function inside. Now, so that I didn't run out of room on this page and I could make this big enough to see, I did this derivative over here. We've encountered something like that before. Half times that to the negative a half times the derivative of what's inside. The 2's cancel, we've got x over the root, and I put that derivative in here. Now, I'm supposed to evaluate this when x is 4. When you put a 4 in here, 4 squared is 16 plus 9 is 25. The square root of 25 is 5, and that's why they gave you this up here. These have to be carefully rigged by whoever makes up the question so that you've got enough information. The x is 4, so that's just a 4, and this works out to, again, the square root of 25, which is 5. Simply put in the value, negative 2 times 4/5, and you get negative 8 over 5. So just rest assured that when they give you this, it's kind of like a puzzle. They've given you all the pieces. That number, although it's not evident at the start of the question, will show up as you proceed through the question.